we will do some integration. Suppose this integration, say 0 to pi sin x dx. How you will integrate this? Can anyone tell? What is the integration of sin x?
Cos x.
Cos or minus cos?
Minus cos
Minus
x.
cos.
Minus cos x. X limits from 0 to pi. So it will be minus cos pi plus cos 0. Cos 0 is 1.
1.
So what is the value? Cos pi is minus 1. So 1 plus 1, that is 2. Value is 2. Here what we are doing? We are integrating sin x. Then we are putting the limit. So that is the process. Now suppose another integration I am giving 0 to pi x to the power 3 by 2 e to the power minus x by sin cube x plus x to the power minus 3 into e to the power x tan x dx. Can you integrate this? Hello, can you integrate this? If you integrate this function, then you can only do this, but not all functions are integrable. Means whatever doing, basically if you remember, suppose we have to integrate a to b fx dx. What will be this? Suppose if we get a function g such that derivative of gx equal to fx, that case what will be this? This value will be gb minus ga. Correct or not? Hello. If we get a function gx such that derivative of gx equal to fx, then a to b fx dx value will be gb minus ga. Is that okay? Hello.
Yes,
It
sir.
is okay. Now not all function we will get in that form. So that's why we require numerical integration. Now before going to that, do you know what is the meaning of a to b integration fx dx? What is the meaning of integration a to b fx dx? That will be area. Area of which portion? Suppose this is y axis, this is x axis. Then suppose in between a to b, this is the curve. This is the point A, this is the point B. Suppose the curve is fx, then this area represents the integration a to b fx dx. Correct or not? Hello. A to b fx dx, that is nothing but area under the curve fx and x axis in between x equal to a to x equal to b. Is that okay? All of you reply. Is this okay?
Yes,
Meaning
sir.
of a to b fx dx. So since we not always we will get a function gx such the derivative of that means fx not always integrable. That's why what we will do, we will divide this AB interval into n equal subinterval, each of same length. Each of same length. Basically what we will do, we will divide this A to B interval by different points this way into n equal subinterval. How n equal subinterval? Suppose first point is x0, second point x1, third point x2. That way v equal to xn. Basically, suppose this is our interval A to B. We will divide into equal subinterval. N equal subinterval by the points x0, x1, x2, x3 and so on. This is xn, xn minus 1. Then what is the length of each subinterval? Total length is, what is the total length, interval length? A to B. What is the length of the interval? Reply. B minus A. If small subinterval length is h, total n subinterval, so n into h equal to b minus a. Are you getting the point? Total n subinterval, each of length h, so nh equal to b minus a. Is this okay? Hello? Is this okay?
Yes, sir.
Now, what we will do? We will divide into small strip. So, this, that way we will divide into small strip. So, A to B integration will be, that will be sum of all the integration in small interval. And in trapezoidal rule, what we are doing, the curve is approximated by straight line. Straight line means A to x1, we are considering different color I am using this straight line. Then x1 to x2, this straight line. Then x2 to x3, this one, this one. That way we are considering. Okay. Then A to x1. What is the area? A to x1. What is the shape? Trapezium. Integration A to x1. What is the shape? That is a trapezium. And suppose functional value at x0, x1 are f0, f1. That we will get from the value. D8 is fn. Then A to x1. What is the integration? A to x1 means x0 to x1. x0 to x1 fx dx. x0 to x1 fx dx will be, what is the area of a trapezium? Half into sum of the parallel sides. What is the sum of the parallel side? This height f0 f1. So half into f0 plus f1 into h. That is the area in the interval x0 to x1. Is that okay?
Yes, sir.
Then what will be from x1 to x2? Half into f1 plus f2 into height. What is the small interval height? H. That way, what will be the last one? That way it will continue xn minus 1 to xn fx dx will be half into fn minus 1 plus fn into h. Is that okay? Is this okay? Hello? Now what is the area? Integration a to b fx dx. So that will be x0 to xn fx dx, because x0 is a, xn is b. That we can write integration x0 to x1 fx dx plus x1 to x2 fx dx, that way up to xn minus 1 to xn fx dx. First one is half into, I am writing h first, f0 plus f1, then half h f1 plus f2. That way it will continue half into fn minus 1 plus fn. So it will be h by 2 common. See, f0 occurs only once, f1 occurs 2 times, f2 occurs 2 times. So first and last occurs only once, remaining occur 2 times. So 2 times f1 plus f2, that way up to fn minus 1 plus fn. This is the area. So ultimately what? But trapezoidal rule, a to b integration fx dx is, if h is the length of small subinterval h by 2, then functional value at the point x0 plus 2 times functional value at the point x1 x2 up to xn minus 1 plus functional value at the point xn. This is trapezoidal rule. Is this okay?
Yes, sir.
Okay. I will show you a notes so you can get it easily. In fact, Joydev sir will share also. I think Joydev sir shares in the notes or not?
Yes, sir. Same.
Yes, sir. Yes, sir.
Maybe same notes. So a to b fx dx, x0 to xn fx dx, x0 to x1 fx dx, x1 to x2, x2 to x3, that is xn minus 1 to xn. So x0 to x1, this one. This side is f0, this side is f1. So half h f0 plus f1. x1 to x2 half h f1 plus f2. That way half h f2 plus f3. Half h fn minus 1 fn. If you see f0 and fn only occurs only once, remaining value occurs 2 times. So h by 2 f0 plus 2f1 2f2 up to 2fn minus 1 plus fn. That is the trapezoidal rule. What is the thing? See, n is the number of subinterval. So if n is small, sorry, if n is large, if we take more number of point, then the whatever we are taking approximated by line, that will coincide with the curve. If we take n large, means if we take more number of points, then whatever straight line we are considering instead of curve, that will coincide with the curve. That's why if we take more n, we will get accurate value, more accurate value. Is this okay? Hello.
Yes, sir.
Now one thing, error in trapezoidal rule. What is the error in trapezoidal rule? Achha, before that I am writing the formula only. So trapezoidal rule, main thing I am writing, that is a theory part how it is done. Suppose we have to integrate a to b fx dx. So interval ab we will divide into n equal subinterval. So by the points x0 ab we are dividing into n equal subinterval, say by points, subinterval by points. Say a first point is x0, x1, x2, last xn minus 1, and last xn is b. Suppose corresponding functional value are f0, f1, that we can calculate from the table, fn minus 1, fn. then a to b, from that one relation we will get n into h equal to b minus a, because n subinterval each of length h. H is the length of small subinterval, length of small subinterval. Then a to b fx dx equal to h by 2 f0 plus 2 times f1 f2 up to fn minus 1 plus fn. This is the formula for trapezoidal rule. And error in trapezoidal rule, error, that is epsilon minus, it will be nh cube by 12 into f double dash t. nh cube by 12 into f dash t cap, or we can write minus b minus a whole cube by 12 n square into f dash t cap. One thing, if n goes to infinity, what is the error term? Error goes to 0, because 1 by n square goes to 0. That's why if we take more number of data point, then value of the actual value and value of the integration this way, they are almost equal. Okay, now one questions we will do. Suppose we have to integrate 0 to 1 1 by 1 plus x square, so dx by 1 plus x square by dividing into 4 subinterval by trapezoidal rule. Dividing into 4 subinterval. So what is n value? So what is fx? 1 by 1 plus x square. Is that okay? Reply.
Yes, sir.
Yes.
What is a? A is 0, b is 1, n equal to 4. This data we have. What will be h? b minus a by n. So 1 by 4. Then what are the points? x0 equal to 0, x1 equal to 1 by 4, x2 equal to 2 by 4, x3 equal to 3 by 4, x4 equal to 1. These are called nodes. So we divide the interval by these points. Is that okay?
Yes, sir.
Now we have to write the corresponding functional value. So what is f0 functional value at the point 0? f0 is functional value at the point x0. So f of 0. What is f of 0? What is f of 0? 1. 1 by 1 plus 0 square, 1. f1 is f of x1. f of 1 by 4. What is the value? Anyone tell? 1 by 16. So 16 by 17. Is that okay?
Yes, sir.
Then what is f2? F of x2, f of 2 by 4 means f of half. 1 plus half square means 1 by 4. So 4 by 5. Is that okay? 1
Yes, sir.
plus 4 by 5. Correct. What is f3? F of x3. F of 3 by 4. F of 3 by will be 9 by 16. 16 by 25. F4 equal to f of x4. F of 1, that is half. So by trapezoidal rule, by trapezoidal rule, 0 to 1 dx by 1 plus x square, that will be h by 2. Then f0 plus 2 times f1 f2 up to f1 f2 f3. First and last occurs only once, remaining occurs 2 times. This is the formula. What is h value? What is h value? 1 by 4. See here, h equal to 1 by 4. So 1 by 4, that is 1 by 8, equal to 1 by 8. I will send you the link. f0 is 1. 1 plus 2 times f1. f1 is 16 by 17. 16 by 17 plus 4 by 5. 16 by 17 plus 4 by 5. f3 plus 16 by 25 plus 16 by 25. f4 is half plus half. This is the value of the integration by trapezoidal rule. Is this okay? This question is okay?
Yes, sir.
Here you have to remember only formula and what is h, what is n. Basically, number of subinterval or subinterval length, that will be given. If you see the formula, see h by 2. H is the length of the smallest subinterval. So if n subinterval, n into h equal to b minus a. You have to remember that relation. Then f0, f1, f2, fn, they are the value at the point x0, x1, x2, xn. One question is done here. 1 to 7 dx by x cube plus 1 for n equal to 6. Means 6 subinterval. So here fx equal to 1 by x cube plus 1. Interval of integration 1, 7. That is given. N equal to 6. So what is the length of the subinterval? H is b minus a by n. 7 minus 1 by 6. That is 1. So what are the nodes? We start from 1, 1, 2, 3, 4, 5, 6, 7. These are the nodes. These points we are calculating the value f0, f1, f2, f3, f4, f5, f6, that we are finding from the function, because function is 1 by x cube plus 1. Then by trapezoidal rule, 1 to 7, this one will be h by 2 plus f0 plus 2 times functional value f1 up to f5 plus f6. Then we are putting the value. That way you have to do the integration. So this is our trapezoidal rule. Trapezoidal rule is clear for all of you?
Yes, sir.
Then another thing, that is Simpson one-third rule. So what is that? Trapezoidal rule, we are taking only one sub-interval. See, what we are basically so I am going to Simpson one-third rule. Simpson one-third rule. Why name is one-third? That will be clear from the formula. There is a proof, but you have to remember only formula. So what we are doing here? Idea is, suppose this is x-axis, y-axis. Suppose curve is, say this one is the curve. This is the point A, this is the point B. Again, same way, we will divide into n sub-interval equal length. After that, suppose, sorry, that way, say this is x0, x1, x2, x3, x4, this is xn, this is xn minus 1. We will consider two sub-interval at a time. I am denoting this with a different color. Here we will consider consecutive two sub-interval at a time. In trapezoidal rule, we have considered only one interval. But here we are considering two sub-interval at a time. Then this curve, suppose functional value same way, I am writing it here, say f0, f1, f2, f3, f4, that we will calculate the function fn. The curve is consecutive to subinterval. Curve is approximated by a second degree polynomial that passes through these points. This is the approximation. We will, instead of straight line, to consecutive subinterval, we are, means, suppose x0, x1, x2. This subinterval we are considering. Two consecutive subinterval we are considering. And these things we are approximated by a 3 points by Lagrange polynomial of degree 2. This subinterval, instead of the function, we will approximate it by Lagrange polynomial of degree 2. Because 3 data points, that's why whatever polynomial, that will be of degree 2. And using that, if we do the integration, what value we will get? X0 to x2. Details calculation is there, but proof is not here. If you are interested, you can go through the book. So x0 to x2. What will be the integration? X0 to x2. If you do the integration, it will be x0 to x2 fx dx. That will be h by 3. 3 points x0, x1, x2. Functional value at the point first point, 4 time functional value of the point middle plus f2, that is x0 to x2. Then x2 to x4 fx dx, what will be the formula? h by 3. Functional value at the point x2, that is f2. There 4 times functional value at the point f3 plus f2, f3, f4. Then x3 to x4, sorry, x4 to x6, fx dx will be h by 3 f4 plus 4 times f5 plus f6. That way it will continue. What will be the last interval? Last one will be xn minus 2 xn fx dx. What will be this? h by 3 fn minus 2 4 times fn minus 1 plus fn. Is this okay? Hello.
Yes, sir.
Now what will be the total integration? We will add all those things. If we add all those things, f0 occurs how many times? If we take h by 3 common, f0 occurs only once, fn only once, f1 occurs 4 times, f3 occurs 4 times that way. But f2 occurs how many times? Here, here, 2 times. f4 here and here. So ultimately what will be the value of the integration? So a to b fx dx, that means x0 to xn fx dx. That will be sum of all those things. If you see the formula h by 3, then f0 fn occurs only once. So f0 plus fn plus see f1 f3 f5 or odd index occurs 4 times. So 4 times f1 f3 f5 up to fn minus 1. Remaining even index occurs 2 times, f2 f2 f4 f4, but fn occurs only once. So that will be 2 times f2 plus f4, that is up to fn minus 2. This is our Simpson 1/3 rule. 1/3 h by 3 is there, means subinterval length, 1/3 of the subinterval length is multiplied, that's why name it 1/3. So this is formula for Simpson 1/3 rule. Formula is clear? I will show you the notes here. Don't go through this one. If you are interested, you can go through it. It will be a to b fx dx. Same way, we will divide into n equal subinterval each of length h, then h by 3 f0 plus fn, functional value at the point first point plus last point, plus 4 times functional value at the point odd index point, plus 2 times functional value at the even index point. Is this okay? Formula is okay? Hello? Formula is okay? Reply. All of you reply. Formula is clear or not?
Yes, sir.
Okay. Then error is given here, minus nh cube by 180 fourth derivative of t cap. So b minus a whole to the power 5 by this. So as n is larger, the error will be less. You have to remember the formula. Not don't derivation. Error formula you have to remember. Okay. Now see one question is here. Same question is done by Simpson 1/3 rule. What will be n, even or odd, for Simpson 1/3 rule? N is even or odd for Simpson 1/3 rule? We are taking two subinterval at a time. That's why n must be even. So number of subinterval will be even. Is that okay?
Yes, sir.
For Simpson 1/3 rule, number of subinterval will be even. N will be even. So you can remember this way formula. H by 3, Simpson 1/3, so subinterval length by 3. Then f first value plus last, f0 plus fn. 4 times odd indexed value, 4 times f1, f3, fn minus 1. Remaining even index 2 times, 2 times f2, f4 up to fn minus 2. Okay. Then see, one question is done here. Same question. 1 by x cube plus 1 by n equal to 6 by Simpson 1/3 rule. Again, interval of integration 1 7 n equal to 6. Length of sub h is b minus a by n 1. So nodes are 1 2 3 4 5 6 7. F0, F1, F2, F3. Just like earlier, it is calculated. Then Simpson 1/3 rule. H by 3, first plus last. F0 plus F6. 4 times odd index, F1, F3, F5. 2 times remaining even index. So remaining are except 0 and 6, so 2 4, F2 plus F4. That way it is calculated. Is this okay? Hello? Suppose we are doing this question, say integrate 0 to 4. Integration 0 to 4 dx by, I am taking a simplest example, 1 plus x by, or say 0 to 0 to say 4 by Simpson 1/3 rule, taking smallest subs interval h equal to, by taking h equal to half. So what are the things here? Fx equal to 1 by 1 plus x. Okay, h is half. So a equal to a 0, b equal to 4. That is given. What are the nodes? Nodes are x0 0, x1 half, x2 1, x3 3 by 2, x4 2, x5 5 by 2, x6 3, x7 7 by 2, x8 each 1. Nodes are clear? Hello? Nodes are clear?
Yes, sir.
So what is f0? Functional value at the point x naught. What is f of x naught? F of 0 is 1. What is f1? F of x1. x1 is half. F of half is 1 by 1 plus half. 1 by 3 by 2, so 2 by 3. Is this okay? 1 plus 2 by 3. What is f2? At the point 1. At the point 1 value will be half. f2. f3 at 3 by 2. 1 plus 5, 5. So it will be 2 by 5. F2, F3. F4. F4 means value at the point 2. That is 1/3. F5. F5 means at 5 by 2. 1 plus 5 by 2. 7 by 2. So it is 2 by 7. F4, F5. F6 at the point 3. 1 by 4. F7 at 7 by 2. 1 plus 7 by 2, so 2 by 9. Then f8 value is 1 by 1 plus 1. f8 value is half. Values are clear? I think one value is wrong, f2. Oh, sorry, it is wrong. f8 will be at x4. x8 is 4. x8 is 4. So f8 will be 1 by 5. So functional values are clear? Hello? Clear or not functional values? Hello?
Yes, sir. Yes, sir.
Okay, then by trapezoidal rule 0 to 4 dx by 1 plus x, so it is h by 3. Then functional value first and last, f0 plus f8. Odd index, it will be multiplied by 4. 4 into f1, f3, f5, f7. Remaining even index, it will be 2 times. What are the remaining even index? f2, f4 plus f6. This is the value of the integration. Formula is clear? H value was half, so it will be 1 by 6. f0 plus f8. 1 plus 1 by 5. 1 plus 1 by 5. 4 times f1, f3, f5, f7. 2 by 3. 2 by 5. 2 by 7, 2 by 9. 2 by 3, 2 by 5. 2 by 3, 2 by 5. 2 by 7 plus 2 by 9. Plus 2 times 2, 4, 6. f2. Half, 1/3, 1 by 4. Half, 1/3, 1 by 4. Do the sum. That is our value of the integration. Is this okay? Hello? Is this okay?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay. Okay. I will share this link in the chat box. So class is clear or not? First tell me. Because way of teaching is different for different teacher. Tell me that all. Class is okay?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So you go through the integration part and the remaining portion Joydeep sir will start next class. Okay. Bye.
Thank you, sir.
Thank you, sir.
Okay. Bye.
You. Thank you, sir.